Good afternoon, everyone. Steve Robinson, Chief Revenue Officer, ORock Technologies. Today, I wanted to accomplish a couple things. One, get you familiar with ORock in terms of where we play in the AI ML space. Two, go through some interesting use case in terms of how you apply our integrated vertical stack around AI ML. And then three, get to questions that you may have from what you've seen. So ORock is 7 years in our maturation. We are government grade secure cloud. We're FedRAMP moderate, DISA impact level 2, as well as FedRAMP high and DISA impact level 4 or 5 ready. You can find us out on the FedRAMP marketplace. We were the first to market around OpenStack and OpenShift government compliant cloud resources for compute storage and Kubernetes. And we have a very exciting partnership with a very innovative company called SambaNova Systems that powers our AI cloud. This cloud is vertically integrated from the chip level up into the compiler, into the software that does all of the workflow management, as well as the open source AI ML development frameworks like PyTorch and TensorFlow. It really is the only vertically integrated solution delivered as a service. Our wrapper around that as a cloud delivery model includes the network that we've built around our data center nodes. So we have our own privately managed fiber, layer 2 fiber that goes between our nodes that gives us leverage in terms of taking data out of the cloud. So we charge 0 egress fees, 0 backend data transaction and access fees. So our market philosophy is that the customer owns their data and they should be able to move that data, access that data, compute on that data freely without any kind of metering that is applied to it. Next slide. So as we get deeper into our ORock AI Cloud stack, the thing to remember around this domain is the incredible amount of GPU, typically GPU compute power that's required to execute these models. There's two sides to the ledger. And there's obviously training the model, and then there's actually gaining inference from the model or executing the model. Typically on historical GPU-based architectures, you're talking racks upon racks of infrastructure to go deliver that. And that architecture typically isn't vertically integrated through the compiler down to the chip level. So SambaNova has created an architecture that's called RDU. It's a data flow architecture that optimizes memory and provides better memory capacity around the execution of algorithms and gives that back to the resources that are consumed by the algorithm. And so at the net level, what we're able to achieve is a significantly smaller infrastructure footprint for like algorithmic execution versus what you would see with just generically GPU-based architectures. In this case, you're seeing an algorithm that was trained and ran that basically took 8.5 racks of GPU-based architecture and compressed that into a quarter rack of ORock AI Cloud. The other thing that I would mention is the ability to gain inference in very small batch sizes. Typically with again a GPU architecture, you can achieve the insight, the inference, but you have to do it with petabyte scale data, both on the training and the inference side. The other leverage of value that this brings to the architecture is the ability to use batch size 1, so very small batch size in terms of training the algorithm and then gaining inference of the algorithm out in the field. Next slide. So I wanted to kind of peel this back, be a little more illustrative in those positions around the architecture. So what this is showing you left to right is the ROI that you gain on vision. So vision, there's really 3 primary algorithms out there. There's NLP, natural language processing, there's vision, and then recommender. And then there's mathematically oriented algorithms for the science community in the lab and research community. So what this is showing on vision is that you basically hit an ROI wall, right? It's not necessarily that you can't get higher pixelation or resolution, but to do it is extremely cost prohibitive when you start talking 4K image, let alone 50K by 50K. And if you think of the DoD and the federal context for this can be very significant. So when you pair that footprint of architecture, the smaller inference point, with the ability to get to much greater magnitudes of resolution with a smaller footprint, and then map that into batch size 1, where you're actually gaining insight with significantly smaller footprint of data, you can see the power of this platform delivered as a service on a kind of either a reserved instance or an elastic model, or API model out to the end customer or enterprise. So that's a very important thing. So again, we're not claiming that you can't do higher resolution on other architectures. What we're saying is your ROI is significantly hampered. You hit a wall versus the ORock AI Cloud in this regard. Next slide. The other thing that you gain, and again, I'm just double clicking on one primary use case, that being vision, is this trade-off between patching and downsampling. So if you think about patching, right, if you want to get a certain fixed level of resolution or pixelation, typically you've got to, take a smaller slice of the field of view that you want to go run the algorithm against, and then the quality of the output is hampered by that because you're taking smaller patches in the edges of the image. There's data and information that gets lost. The other is downsampling, where you're getting large field of view, with large features, but you're losing the details and the low resolution. With the ORock AI Cloud, there is not a compromise. This is due to some of the points I've made earlier around the availability of memory in the batch size, the smaller rather batch sizes that the platform can operate on, and so that you don't really get this or, you get this and. You can have large field of view, large surface area of imagery that you're analyzing, and also maintain the high resolution and high pixelation as high as 50 by 50K. So the application of this, I think, is very obvious in terms of healthcare, in terms of military context, satellite imagery that you're trying to do analytics on, and others that we could talk about. But the important thing is it's data scale. The chip level of data flow over this architecture, and clearly we don't have time to go deep on that architecture here, but we can and explain how that works, is gaining you significant output and insight and inference around this at a considerably cheaper ROI. Next slide. So just kind of wrap it up here. Accuracy, clearly the performance, we've touched on that, but accuracy is a very key ingredient to AI ML yield. Training models is good if that's great that you can do it at scale on legacy architectures, but you lose the accuracy of the data and the inference. And so again, where this is not an or, it's an and. You gain that performance gain in terms of lower latency and things on the chip, but you also maintain and improve and enhance the accuracy without having to go through petabytes of training. Petabytes of data on the training. You can do it at terabytes level of training to get that level of accuracy. Scale, starting small and then scaling out with no code changes. And then I touched on this on my first slide, but then we want to make this and wrap this into a cloud experience and make it very easy to consume. So existing models that have already been trained on GPU-based architectures can be ported into and recompiled down into this stack. What that means is we've developed a CUDA free, if you're familiar with the NVIDIA architecture, it's a CUDA free computing environment without vendor lock. Many times we can just port it over and run it. Other times we need to port it over and use a code wrapper that gets put around it and compiled down into the chip and then execute. And then the predictability of the cloud model and the movement of the data and the bits over the wire. Again, ORock is very specialized at the network layer in terms of getting the data in and out and the data maturity model to execute the algorithm. That's a big benefit. And of course, we're, as I opened with, I'll close with a government grade cloud that's being used today in all parts of the DoD and many parts of the federal civilian landscape. Next slide.
And Steve, I just want to let you know you're 10 minutes in to your 12 minutes.
Perfect, perfect marker. So why partner with ORock, right? We're seeking active partnerships, vested interests and thought leadership around this, an ecosystem. The partner value prop is very high. We've created an easy button around this to work with portfolios. We can help bring a significant TCO factoring to these AI/ML customer conversation in terms of where these algorithms are developed, the portability of the algorithms from existing infrastructure, legacy infrastructures, and then the execution with higher gain on the inference. White glove support. Again, we constantly monitor this environment. We're held to a FedRAMP and a DoD impact level standard of monitoring. They call CONMON, continuously monitoring and metricing around our support. And then flexible services engagements based on partner skills where we can go partner together and have a win-win outcome. So I'll stop there and we can go to Q&A.